Hi everyone, I am Rekha, Assistant Professor, Department of Mathematics. So today we are going to discuss about the basic definitions of the transportation problem. So let us see what are the basic definitions of the transportation problem. So to solve the transportation problem, you need this type of the definitions. Based on this definition only you can solve this transportation methods. So first of all you have to recall what is feasible solution, then basic feasible solution, and last one is optimization solution. So basic feasible solution, so everyone know that, and the transportation problem, that is we have to check whether it is a non-negative allocations or there, whether it is a row and a column will satisfies the restriction. And the basic feasible solution is nothing but we have to check m plus n minus 1, that is non-negative value. So m always represents the rows and whereas the n represents the column. So optimal solution is whether the problem is nothing but a minimization or else maximization, the problem is called as an optimal solution. So these three definition is very important for the transportation problem. So and also there will be a cases, if we got the solution means you have some two cases are there. One is non-degenerate feasible solution and another one is that is degenerate basic feasible solution. So what is mean by non-degenerate solution is nothing but m plus n minus 1 is equal to the number of allegation. If the m plus n minus 1 value should be equal to the number of allegation means then the problem we can say it is a non-degenerate solution. So I will give one example for that. So m is nothing but 5, n is nothing but 3, 5 plus 3 8, 8 minus 1 you will get, what is 8 minus 1? 7. Number of allocations should equal to 7. So if it is 7 means we can say it is a non-degenerate solution. So what about the degenerate solution? Same concept, m plus n minus 1 is called as a degenerate solution if that is 5 plus 3 minus 1 equal to 7 means if you got the allegation as 6 only, then it is not at all equal. At the time the degenerate basic solution will exist. So for that problem what we have to do? So let us see what is how will you solve for this problem. Degeneracy transportation problem occurs in some cases of the problem means we have to say that the m origin and destination should be less than m plus n minus 1. This is the definition for the degenerate solution. So for this case what we have to do? We have to add sum of an element epsilon for this problem. So if a loop was formed or a lower cost is chosen means any area with the lower cost we can choose a value. For example, you can choose an epsilon for that. So epsilon takes the minimum value for that problem. So epsilon is nothing but a minimum value for that problem. Then so epsilon is nothing but minimum value we are going to decide for this problem. So minimum value normally epsilon. So epsilon takes the value 0 in that problem. So epsilon should be greater than 0 means the allegation is not necessary. If epsilon is less than 0 means we can allocate one of the least value. So you can tends to 0. So instead of epsilon the value is normally tends to 0. So now the degeneracy problem will get balanced. Then finally you can go continue the problem with the 8 allegation. Now the number of allegation is equal to 8. So this is also 8, hence it is equal. And another definition is main definition. We can see it is an what is balanced transportation problem. Balanced transportation problem is nothing but summation ai equal to summation bj. Then we can say it is a balanced transportation problem. So that is supply should equal to the demand. So we can say it is a balanced transportation problem. Whereas an unbalanced transportation problem means the supply need not be equal to the supply and as well as the demand. So for this case we can go with the unbalanced transportation problem. So this unbalanced transportation in that available resource is not used or some rim requirement will remain unfilled. So this is the main condition for the unbalanced transportation problem. So balanced transportation, unbalanced transportation, what is the difference? For the balanced transportation problem, no need to, we can continue the problem. For else unbalanced transportation problem, we have to add a dummy variable with 0 constraints and then we have to solve the problem. Then you can get an allegations for that. So this type was nothing but an unbalanced transportation, so with 0 constraints. So based on this definition, we can easily go with that unbalanced transportation problem and solving the transportation problem using the basic definitions. So thank you students. We can see the video. Okay.